لاني بامثل منظمه دوليه عربيه، فاتحدث باللغه العربيه احتراما لمنظمتي التي انتمي اليها. بدايه اتقدم بكل الشكر والتقدير الى الساده منظمي هذه الندوه، سعاده المهندس سالم الحبيط، الخبير المعتمد في مجال الطاقه المتجدده وعضو مجلس اداره المجلس العربي للطاقه المستدامه بالاتحاد العربي للتنميه المستدامه والبيئه، والى سعاده الدكتور بدر الطويل، رئيس قسم تكنولوجيا الهندسه الكهربائيه ونائب رئيس المجلس العربي للطاقه المستدامه بالاتحاد. لا يفوتني ان اتقدم بكل التقدير والشكر الى الساده المتحدثين، سعاده المهندس سعيد بالحداد، مستر روبرت جول، الدكتور حسين باسي، مهندس احمد العزمي، دكتور مصطفى التومي، دكتور هاني محسن، السيد عمر مسعود، ومستر فرانكو جوفي. بتقدم لهم كل الشكر والتقدير، ولا يفوتني اني اتقدم بكل التقدير الى جميع الساده اعضاء مجلس اداره المجلس العربي للطاقه والهيئه العلميه الاستشاريه الخاصه به برئاسه المجلس، برئاسه الدكتور المهندس محمد اليماني، وسعاده السفير جمعه الكعبي. في الحقيقه انا النهارده سعيد باني بشارك في الندوه العلميه التي يقدمها المجلس العربي للطاقه المستدامه عن الابتكار في مجالات الطاقه المتجدده، ومش جديده الحقيقه على الساده اعضاء مجلس الطاقه المستدامه مهندس سالم والدكتور بدر في تقديم الجديد والمفيد لامتنا العربيه. دائما ما اتحفونا بالندوات والدورات وورش العمل اللي بيقدموها لخدمه العمل العربي المشترك والرفع كفاءه جميع مواطني المنطقه العربيه اللي بيستفيدوا الحقيقه من هذه الندوات وهذه الورش التي يقدموها. انا بشوف ان عدد المشاركين دايما في الندوات التي يقدموها والدورات بيبقى اعداد كبيره جدا وبكثره ومتنوعه من جميع الدول العربيه، والحقيقه يمكن في مشاركين من دول اسيويه او دول اخرى اوروبيه. احنا كالعاده دايما بنحاول ان احنا نطور من انفسنا، وبنحاول ان احنا نقيم الندوات والدورات وورش العمل. يمكن في الفتره الحاليه ان احنا بنقدم هذه الدورات والورش اونلاين بسبب جائحه كورونا التي المت بالعالم اجمع. الاتحاد العربي للتنميه والمستدامه والبيئه دايما بيعمل، يمكن كان عندنا المؤتمر الدولي كان في شهر سبتمبر الماضي، وكان مشارك فيه معظم الاخوه الموجودين من الاتحاد والمجلس العربي للطاقه. عندنا مجلس تمكين ابحاث التنميه المستدامه ايضا، ومن جميع الجهات الموجوده والمنظمات الدوليه والجامعات العربيه والمصريه اللي بنتعامل معاها. النهارده المجلس بيقدم لنا الندوه، وارجو ان تكون ندوه ان شاء الله تكون موفقه ويستفيد منها جميع الساده المشاركين. بكرر شكري للساده منظمي ومنسقي ومديري الندوه، والى مجلس الطاقه المستدامه والهيئه الاستشاريه رؤساء واعضاء ونواب. وبشكر جميع المشاركين من المشاركين النهارده في هذه الندوه سواء بالاستماع او بالمناقشه. وبكرر شكري لكل الساده المتحدثين ليقدموا لنا الجديد من علمهم. بارك الله فيكم جميعا، اشكركم، والسلام عليكم ورحمه الله وبركاته.
وعليكم السلام ورحمة الله وبركاته دكتورنا أشرف، يعطيك العافية. ولا شك أن دوركم كاتحاد وأيضا كمجلس العربي للطاقة المستدامة يشجعنا نحن كأعضاء نستمر في هذه الندوات، ونتمنى إن شاء الله أن يكون لها كثير من الفائدة للمجتمعات العربية والدول العربية والمجاورة والصديقة. يعطيك الف عافية دكتور. For our webinar, we have, as scheduled earlier, the first speaker we will have is Engineer Saeed Balhadad. He is a General Director of GCC Lab for Renewable Energy that is located in Saudi Arabia. And this I think each speaker has 20 minutes of time. We hope all of us will enjoy the time with our speakers. Engineer Saeed, تفضل.
شكرا أخوي سالم، يعطيك العافية، وأشكر لكم أيضا كذلك دعوتكم للمشاركة في هذه الندوة. نسأل الله سبحانه وتعالى أنه يكون ما نقدم فيها ينفعنا جميعا. I would like to apologize for our colleague who is not Arabic native speakers that my presentation and my speech is going to be in Arabic, and wish you to have a chance next time to have another event so we can have a more deep technical dialogue with you gentlemen. إذا تسمح لي أخوي سالم أنا بسوي شير سكرين للبرزنتيشن.
تفضل.
يعني تعلن عوامل نجاح تطبيقات الطاقة المتجددة في الوطن العربي. وخلال هذا العرض بإذن الله تعالى سنتكلم أولا عن خلفية عامة على
انجينير مهندس سعيد. I'm not sure if I'm the only one who has the difficulty.
ألو؟
اي نعم. أنا ما أدري إذا الخلل من عندي أو من عندك، لأن كان في بطء شوي في عملية الشير سكرين. Mr. Robert, is it?
I can see it.
I
can see his screen. Yes.
Okay. Go ahead, engineer. تفضل.
طيب يعطيك العافية. طبعا أولا يعني الطاقة المتجددة تعتبر منظومة طاقة مستدامة، وأصبحت الدول تنحو بهذا المنحى حتى يتجنبون الاعتماد على الوقود الأحفوري اللي هو يعتبر مصدر غير مستدام للطاقة، وأيضا كذلك إحدى أهم الأهداف لتخفيض انبعاثات ثاني أكسيد الكربون اللي تنتج عن استخدام الوقود الأحفوري. لذلك الأمم المتحدة اعتمدتها كإحدى أهداف خطط التنمية المستدامة لدول العالم بعام 2030، بما أن الطاقة المتجددة طبعا لها دور بارز في الحفاظ على البيئة. دول العالم في الفترة الماضية اعتمدت استراتيجيات بحيث أنها تواجه الزيادة في أعداد السكان، وأيضا كذلك الزيادة في النمو الصناعي في هذه الدول من خلال الاعتماد على مصادر الطاقة المتجددة. فدول مثل الصين، مثل الهند، ومثل الولايات المتحدة عندها هدف أن ثلث إنتاج الطاقة مستقبلا في هذه الدول أن يكون من أنظمة الطاقة المتجددة. عندنا بعض الدول في العالم العربي اعتمدت استراتيجيات بحيث أن 50% من إنتاج الكهرباء حيعتمد على مصادر الطاقة المتجددة. طبعا دول مثل الصين والهند والولايات المتحدة بعدد السكان الكبير اللي موجود فيها أيضا كذلك، هم يعني خططهم الموجودة حاليا تمثل ثلثي الأهداف محطات الطاقة المتجددة على مستوى العالم. بالذات الصين اللي احنا نلاحظ بالرغم من الكورونا الفترة الماضية هي الدولة الوحيدة اللي تقريبا تعتبر يعني حققت أهدافها لسنة 2020 فيما يتعلق بالاعتماد على مصادر الطاقة المتجددة. طبعا الدول الاسكندنافية بشكل عام والدنمارك بشكل خاص تعتبر من أكثر الدول تقدما في تطوير مزيج الطاقة، حيث أن الطاقة المتجددة في دولة مثل الدنمارك تساهم بنسبة 70% من الكهرباء المنتجة في دولة مثل الدنمارك، بينما السويد والنرويج يعني وصل مساهمة مزيج الطاقة المتجددة في مزيج الطاقة إلى 50%. طبعا الأهداف العامة اللي يعني يجب أنه يعني نحن نحوها إن شاء الله تعالى اللي هو نشر تكنولوجيات الطاقة المتجددة المناسبة مع التركيز على إنتاج الكهرباء، أيضا كذلك تطوير البنية التحتية اللازمة للسماح لمشاريع الطاقة المتجددة للتسرب والمشاركة في مزيج الطاقة، سن التشريعات واعتماد المعايير والمواصفات الخاصة بالشبكات والمعدات والنظم ذات الصلة، بالذات إذا أخذنا بعين الاعتبار أكواد الكهرباء في بلداننا العربية، وأيضا كذلك ظروف الطقس والمناخ اللي تعتبر يعني إلى حد كبير جدا يعني مختلفة تماما عن بقية دول العالم، بالذات إذا ما قارناها بأوروبا، أمريكا الشمالية، وأيضا كذلك دولة مثل الصين. تحسين بيئة العمل لجذب الاستثمارات الخاصة، يعني تشجيع المستثمرين الخارجيين بالذات على القدوم والاستثمار في المنطقة، ودعم أنشطة البحث العلمي اللي من شأنها أنها تدفع عجلة التطوير والنمو في مجالات الطاقة المتجددة. طبعا إذا حبينا يعني نركز على الفجوات الموجودة، والتركيز على الفجوات هذا يساعدنا أيضا كذلك في إيجاد الحلول. أهم شيء أن احنا نركز على موضوع تطوير التقنيات ونقل المعرفة. يعني احنا ما نبغى نكون يعني في العالم العربي شعوب استهلاكية، لا بالعكس، نحاول نكون احنا أصحاب الصنعة وأصحاب التقنية، وبالتالي أيضا كذلك نكون يعني مستقبلا بإذن الله تعالى ما في شيء يمنع أن احنا نكون مصدرين لهذه التقنيات وهذه المعرفة. وجود المعاهد التدريبية المختصة والبرامج التعليمية، ولاحظنا مؤخرا بعض الجامعات اعتمدت كوريكولومز أو يعني مسارات دراسية مرتبطة بالطاقة المتجددة. العائق الاجتماعي أصبح شبه اعتيادي، الاعتماد على الوقود الأحفوري أو يعني على مصدر طاقة خلينا نقول سهل أو متعودين الناس على التعامل معه. فبالتالي الآن يعني أنت تحتاج تبدأ أنك توعي الناس بأهمية يعني الاعتماد على مصادر أخرى للطاقة المتجددة، أريح سواء من ناحية بيئية، من ناحية اقتصادية، أيضا كذلك من ناحية يعني لوجستية. وأخيرا وليس آخرا المواصفات الفنية ومدى مطابقتها للأكواد والظروف المناخية في دول العالم العربي. طبعا من عوامل نجاح تطبيقات الطاقة المتجددة أولا إنشاء المراكز الوطنية لبحوث الطاقة المتجددة، وهذه المراكز الوطنية هي اللي يعني يفترض أنها تقود يعني عجلة التحول إلى الطاقة المتجددة عوضا عن الوقود الأحفوري من خلال إصدار التشريعات والأنظمة، وأيضا كذلك يعني تنظيم السوق يعني فيما يتعلق ب يعني مزيج الطاقة. إعداد المواصفات الخاصة بمكونات الطاقة بما يتناسب مع الظروف المناخية في العالم العربي. يعني العالم العربي إحنا ما يخفى الجميع يعني درجة الحرارة فيه عالية، تصل مثلا في بعض دول الخليج إلى 50 درجة مئوية في أشهر الصيف. أيضا كذلك الرطوبة عالية بالذات في المناطق المطلة على البحار، سواء كان في الخليج العربي أو أيضا كذلك كان جنوب الجزيرة العربية أو أيضا كذلك في دول شمال أفريقيا. تدشين المعاهد والبرامج التدريبية لنقل المعرفة وتمكين العمالة المحلية. يعني الطاقة المتجددة تعتبر يعني من أبرز إسهاماتها اللي هو رفع أو تقليل نسب البطالة من خلال توظيف الشباب في هذه المشاريع، سواء من ناحية تركيب المشروع أو تدشينه أو تشغيله. فبالتالي يعني المعاهد التدريبية تساهم في تهيئة القوة البشرية للمساهمة في إنشاء وتشغيل هذه المحطات. تحفيز القطاعين العام والخاص للاهتمام بحفظ الطاقة وكفاءة استخدامها واعتماد الطاقات البديلة، إما من خلال إلغاء بعض الرسوم أو من خلال أيضا كذلك يعني إعطاء يعني شريحة تحفيزية لأي مبنى أخضر يعني يتبع معايير كفاءة الطاقة أو يستخدم أنظمة الطاقة المتجددة كجزء من مزيج الطاقة في ذلك المبنى أو تلك المنشأة. نشر الوعي في جميع قطاعات المجتمع باتجاه حفظ الطاقة واستخدام الطاقة المتجددة عبر حملات إعلامية وتثقيفية. توطين أكبر نسبة ممكنة من سلال القيمة. دولة مثل مصر حقيقة يوجد فيها يعني برنامج واعد جدا لتوطين التقنيات، سواء كانت مصانع ألواح طاقة شمسية، مصانع أيضا كذلك قواعد الألواح، مصانع الأسلاك، مصانع أيضا كذلك الانفرترات. يعني احنا زي ما ذكرت سابقا يعني نرغب في ان نكون شعوب منتجه لا شعوب استهلاكيه، ويعتبر التحول لمجالات الطاقه المتجدده فرصه كبيره جدا ان احنا يعني بدلا من الاستيراد يعني بشكل مطلق من الخارج، ان يكون فيه دعم لقطاع التصنيع المحلي. انشاء دليل تنظيمي للكهرباء لوضع القواعد والاجراءات اللازمه لتنميه تشجيع انتاج واستخدام الكهرباء من الطاقه المتجدده. هذا ايضا كذلك جانب مهم جدا نظرا لما تعطيه من الشعور بالارتياح لاي شخص او منشاه او منظمه ترغب في تمكين مبانيها من انظمه الطاقه الشمسيه. وضع سياسات تحفيز القطاع الخاص للانخراط في صناعه الطاقه المتجدده من خلال يعني تقديم محفزات للقدوم والاستثمار في العالم العربي. حمايه الملكيه الفكريه ودعم الابتكار والبحوث العلميه ذات الصله بالذات فيما يتعلق بقطاع الجامعات والمعاهد، وأيضا كذلك بعض المراكز البحثية الوطنية. وتعميق التعاون مع المؤسسات الدولية والإقليمية المعنية. يعني هذا ما كان لدي في هذا الصدد. إن شاء الله تعالى يكون يعني قدمنا مادة جيدة ومختصرة، وإذا كان لديكم أي استفسار فأرجو منكم عدم التردد في طرحه.
يعطيك العافية المهندس سعيد على ما قدمت من نقاط التي تساعد في نجاح تطبيقات الطاقة المتجددة. ونحن سوف يعني يكون لنا جزء حق الأسئلة في الختام. إذا أي أحد من الشباب عنده سؤال ممكن يكتبه يعني مكتوبا، وحنا إن شاء الله بعدين سوف نناقشه مع بعض. يعطيك العافية. Thank you, Mr. Saeed Balhadad, for your talk. And I think we are moving to the second part of our speakers. We have Engineer Robert Gold to talk to us about the innovations to inventing. We are glad to have you, Mr. Robert. You can start now.
Okay, thank you very much. I greatly appreciate it. I appreciate being here. You have quite great speakers, and I'm glad to be among the group. I'm going to share my screen now so that I can start my presentation. Hold on. There we go. Is everybody seeing my screen?
Yes, I think I can see it.
It says the renewable energy puzzle.
Yes.
Okay, great. Today I'm going to be talking about my concerns about current options for storing renewable energy. This is part of a series that I've put together called Innovation in Inventing. It covers a wide range of topics, and this one is about renewable energy and the challenges faced in storing renewable energy. So let me just, okay. First, in innovation, more than any other factor, innovation in storage technology is at the center of the renewable energy puzzle. This is, innovation is about what is desirable, what is possible, and what is viable. And that is the Venn diagram for innovation. Creating energy in the renewable energy field is already a reality. Creating the amounts needed in most places with most technologies is already accepted. But holding on to that power using realistic technologies until it is actually needed, the major problem where innovation is needed today is holding on to that power. There are 5 basic conventional energy storage technologies. Just to quickly review: electrochemical, which includes all types of batteries; electromechanical, which includes flywheels, pumped hydro, compressed air; chemical, electrical, and thermal. What we have in the way of concerns for all of these are the price, the cost of installing it, the maintenance involved, the production of the actual equipment, the energy output and what you can actually store, the capacity, the life cycle of the equipment, how much it's going to take to replace it in what sort of regular time frame, where you locate the equipment, and the environmental impact. Even with serious shortcomings, there are many accepted energy storage systems active in the marketplace today.
والله كان عندي presentation وانت دقيت وانا في وسط.
Yes, thank you. There are many active in the marketplace today, yet a major age-old technology is just getting started in the renewable energy field. That old school storage technology is weight and gravity-based systems called KESS. KESS, or kinetic energy storage system, is the simple use of some sort of weight being lifted, as shown in number 1, the bike riding up the hill, energy from a renewable energy source, creating the energy to get it up there. Second, potential energy, storing that at a height, and then when the weight is lowered again, as in rolling down the hill, it releases potential energy as kinetic energy, transformed into electric power. All hydroelectric dams are a form of kinetic energy storage and release system. Pumped hydro is the most common use of kinetic energy storage and release. Renewable energy is used to pump water up from the lower reservoir to the upper reservoir, and this is usually done at a time of day when you have the best price to get that power, to use it to pump up. Excuse me. The flow downward creates the electric power. Systems like this use 80 to 95% of the power to recycle itself. So you get a 5 to 15% net power storage to power generation efficiency. And this is very common. Well, what has been known for many years and used in many things outside of renewable energy is that you can use a motor to lift a weight by electric power. That's number one here. The electric power is going in, and that creates potential energy in the weight by lifting it up. The weight stores that energy as long as it's held, which is shown in number 2. And then in number 3, releasing the weight and spinning the motor in reverse causes the motor to become a generator, to generate up to 90 to 95% of the energy it took to wind up the weight. This is very efficient. Weight-based gravity systems are among the best long-term energy storage systems, but like everything, they do have problems. What I want to talk about here to begin with are 4 new technologies that are coming to the marketplace of gravity weight-based renewable energy storage systems. These 4 technologies are not quite on the market yet, but have been approved for funding, have been actually in negotiations to have large-scale purchases, but very few comments have come out about the downsides of these technologies. First, let's talk about the energy vault. This is one of several to come out of Europe, and this one is very simple in as it uses cranes. As you can see, there are 6 cranes here to lift up concrete blocks to store the kinetic energy in these blocks as they're stacked up around the crane. You see here, here's the system with 4 cranes. Actually, you got a 5th one on the top. Minimal charge, half of the charge is up, 3/4, and full storage. Now, this actually is a system, whoops, let's go back a second. This actually is a system that has good potential. You can output power as other power is stored in, and you can store power for long periods of time. But this storage system has problems. Possible collapse from misalignment of the blocks. High winds can affect the swing of the cables during the power generation or movement of the blocks to or from storage. Earthquakes, earth shifts can topple the structure. The number of crane arms limits the power production or storage at any given time, as well as the actual weight of each concrete block. You need to have a massive weight in one location, and you'd have to have either a major foundation built or an area where you place this on a bedrock base. And my favorite, it's a massive eyesore on any landscape. This would have to be much, much larger than a wind farm, and it would be something that people really wouldn't be happy to look at long term. The second energy system is called gravitricity, and this is a Swiss company, and what they've done is they dig a very deep hole, and in that hole they put a weight, and the weight is connected on 4 sides with cables to combination motor generators. When the weight is at the bottom of the hole, they use power from renewable energy to pull this up and place it at the top. And that stores the kinetic energy in the weight of this in the hole. When they want power back, they release the weight slowly, turning these 4 generators, the pulleys as generators, producing electric power and outputting it to the grid as needed. The strengths are that it has a pretty much an instant power response. It has a long life cycle, according to them, of 75,000 uses. Can be built into structures, as you see here at the right. This building has one of the systems built into the basement. You can output power on demand and stop the power when you don't need it. Has a small footprint. Longevity of storage without degradation is very good. Multiple systems can be connected for power amplification, and they're touting 80 to 90% efficiency return on lift power required. All of this is pretty good, but there are problems with this system. Earthquakes and ground shifts, again, can totally destroy this system very quickly. Multiple cable sets and generator motors mean that the failure of one is the failure of the entire system. No power in or power out simultaneous capability. You either put power in or you take power out. You have limited static output per system, although they can be linked together. And if one of the cable sets snaps or snags, you're going to get a weight shift and possible tilting and jamming of the weight in the shaft. And the stability of this long tube, which they say could be hundreds of meters deep, is in jeopardy. A third kinetic energy storage system is called gravity power. It utilizes what's basically a captive pump hydro type system. In operation, a single large piston shown here on the right is pushed upwards in a tube via a motorized turbine up here that uses pressurized water that's placed under the piston. Let me go to the next one. Here, it pumps water from the top, pumps water from the top down under the piston, pushes the piston up. When the piston is at its maximum or any point in between, they can reverse the flow. And now the piston goes down and the water is pumped up through the turbine, spinning the generator, creating electricity. They're only estimating a 75 to 80% efficiency in this. They say it's a low-cost system. I have my doubts about that. No emissions is true, as are the other systems. No continued water use. We'll talk about that in a second. And it should have excellent dynamic response. It hasn't been tried out yet. They're still working on the prototype. But as you can see by the size of the people here up at the top, let me see if I can go back. The size of the people, this is quite a large endeavor, and digging this hole, making it the shaft, whether that's a steel or concrete inner liner, it's going to be a long process to get this done. And it only has the operating capability of a very specific amount of power at any one time. Now, the problems with this system, you must use clean water, or the system will jam up or require major and constant maintenance. You cannot put seawater in here because the salt will be corrosive. The organisms that will come in with the seawater will populate inside of here and cause it to jam up. You have the evaporation problem. If we're talking about installing these in the Middle East, you're going to have major evaporation problems as the land around this is going to be very warm. You have earthquake or earth shift damage that could stop the piston movement as well as causing leakage. There's no power in, power out simultaneous capability. It either works one way or the other. And large quantities of water are needed. and being millions of liters per location and being clean, almost drinkable water, this might be a problem for areas of the world where water is a major concern. The last of the four kinetic energy storage systems that are coming on the market right now, excuse me, I need to drink water. The last of the four is the rail energy storage. The rail energy storage is, well, I have concerns about this right from the beginning, but basically you use your energy from your wind farm to run motors inside of these boxcars filled with gravel or rocks and push them up a track. You can push one, you can push many up a track where they stay at the top of a hill. You need a long slope track to make it work. Then when you want to put energy back in the grid, you let them roll downhill, reversing their motors into generators and creating electric power as they go down. The amount of electric power that could be generated from this is, in my mind, not significant. Number two, you need a large sloped, a large sloped land area, and any snow, floods, high winds, or other physical land changing event can slow or stop the system completely. Major physical maintenance would be required to keep the system operational, as well as you have to lay these tracks, probably dozens of tracks up a hill, so that you can have enough boxcars to store the energy and have them go down. The system can be putting energy in as you're taking energy out, but again, it's not anywhere as efficient as lowering weights in the tube or lowering the concrete blocks as seen in other systems. Now, Cybernite, my company, has developed something called the Power Bank System, PBS, is a renewable storage energy technology that I'd like to tell you about. This is still in the patent intellectual property stage, but it can deliver scalable power on demand in the amount required. In other words, if there's a load on the system that is a couple of hundred or 1,000 watts or a megawatt, the system can output exactly that much power. Small amounts of power or large amounts of power, the system responds to the demand and outputs that exact amount of power, so there's no power wasted. It accepts in as it delivers out. So it has simultaneous in and out capability, and because of that, it also accepts electric, gaseous pressure, rotational power in, and stores that energy in a unique format to be delivered as electrical power out. So whether you have a windmill that is directly connected to this, or it's creating electric power that's putting into it, or you have something creating pressure, whether it's any type of gas, it can be accepted into this system, and the power can then be converted to a storable format where it is available on demand to be output. This system is also built from mostly off-the-shelf parts, so it's very little in the way of things that have to be created to be custom for this. There are a couple of custom parts in it. And it's also modular, expandable, and portable, and they can be connected together to scale out power. So you can have a farm of these containers. The containers can be put on tractor trailers and moved to areas where you need emergency power once they're charged up. And these containers can also be built in such a manner that they can hold a very, very large amount of stored power. So these are Cybernite's new renewable energy storage and production concepts that we currently have in design and production. And if you're interested in discussing using, owning, or selling realistic, viable proprietary technologies to advance your renewable energy production and storage systems, then please contact us about how we might be able to help you or your country to be on the cutting edge of renewable energy technology. And for anyone who would like a copy of this presentation, please email me or contact Engineer Salam, and you can get a copy of this presentation. It'll be available upon request. And I want to thank everyone for listening, and I hope this information was of value to you. And I'll stop the sharing of my screen now and return control to Engineer Salam.
Yeah, thank you, Mr. Robert, for what you show. And I think we are very excited to know more about the energy storage technologies. And you gave us a good brief about the latest technologies. And also you showed some of your innovative idea of storing energy. There is, I think, questions by Muhammad Sardi. We would like you to take it before you stop. He's saying that about registering innovations, what are the areas permitted for registration in terms of general design, mechanism of actions, and current generation of electric current? Also, he has some sequence of questions. If you can check it and answer his questions. You need to turn on your mic, yeah.
Yeah, I'll look at that and I'll answer him directly, and no problem. And like I said, anyone who is watching, please contact me with any questions in email or through Engineer Salem, and I will get back to you. We're looking forward to dialogue.
Thank you, Mr. Robert. And I think Muhammad Sardi, he will get your answers through the questions and answers area. Now we have Dr. Hussain Al-Bassi. He's associate professor in the University of King Abdulaziz, and he's one of the pioneers Saudis who are working in the inventing, especially in the field of renewable energy. So we are glad to have Dr. Hussain Bassi, if he is still with us. Dr. Hussain.
Yes, I'm here with you, and thank you very much, Engineer Salim, for this introduction. I hope everybody is doing very well. Am I clear and loud, or?
Yes, yeah, we hear it very well.
Right, should I get started, or we're still waiting for?
Yeah, you can start your topic by using, if you like, the share screen.
Right.
The bar, yeah.
All right, I will share my screen, and I hope, inshallah, it's gonna work. Okay, just let me know if you guys see anything. Which one is Salim?
Yes,
can you see the presentation? Is it clear?
Yeah, it's clear. We see.
Right. Great. Assalamu alaikum, everybody, and I hope you guys are doing very well. My name is Hussain Bassi, and as Mr. Salim mentioned, I'm an associate professor at King Abdulaziz University, and my discipline is in power engineering. Well, actually, my subspecialty is in power electronics, where I utilize this specialty in renewable energy applications. The topic that I'm going to talk about is inventions in improving the performance of renewable energy applications. And why I'm presenting this topic? Well, actually, I have a couple of patents and publications in renewable energy that actually has a focus on inverters, power electronics devices, and PV panels, especially. So I have been working on patents and the patent system for a while, since 2008, where that was my first application to get a patent in energy or something like that. But then that was the first one. It was the one. It was the pain in the back at that time. You know, I've learned in the hard way. Now, alhamdulillah, I have over I think 9 patents and 10 in the pipeline, and they're all in renewable energy, energy efficiency, and power electronics as application in the renewable energy as well. So what I will be doing now is that I will get over a couple of things together, guys. The first thing is I would love to define what renewable energy is. I'm pretty sure you all know what it is, but just, you know, to have like a common ground, because I've heard a couple of debates about the, you know, the definition. So I thought maybe it's going to be better to have a common description and definition for that. And the second thing is that we would love to know why it's important. I know why, for sure that you know it's important, but I would love to, you know, shed some light on a couple of important things in there. After that, I will talk about the characteristics that need to be associated with the renewable energy inventions. If you would love to invent any new technology in renewable energy, then there are a couple of characteristics out there. What I'm going to present is about 16 characteristics. That's after I shorten, you know, the list. Well, actually, I have about 100, but in general, you know, I will get started with the 16 characteristics. And one more thing, you know, I have only 20 minutes, so I can't go over it forever. So if Engineer Salem said you have only 15 minutes in the beginning, but then I said, I think 15 is not going to be enough. So why did he give you another 5 minutes? Then he's so generous to give me another 5 minutes. And now I have 20 minutes. Anyway, so then I will talk about a couple of challenges in the photovoltaic panels. Engineer Salem is laughing, so. Anyway, I will be talking about some of the, I will focus my talk in the challenges related to photovoltaic panels. Again, I can't mention everything, but I will focus on the major challenges, and I will do the same thing as well for the solar inverters, where I'm going to mention a couple of issues that we need to focus on. And they are like, I would say the seeding point or the starting point where we can get inventions out of. The definition here, I would love to minimize this thing because it's on the way. Okay. Real renewable energy. It says that renewable energy, often referred to as clean energy, comes from natural sources or processes that are constantly replenished. For example, sunlight or wind keep shining and blowing, even if their availability depends on time and weather. So here's the thing. Why I put this definition is because, you know, many people think that nuclear energy is renewable energy. No, it's not. Yes, it's clean, but it's not renewable energy. And as we can see here, we are focusing on the source. I hope you guys can see my mouse. Engineer Salim, can you confirm that for me, please? Can you see my mouse, my pointer moving?
Yeah.
Yes, we can see that.
All right, great. So it's about the source that we're relying on. I heard one of the debates with someone who claims that he's a specialist in renewable energy, saying that renewable energy, actually, it's not renewable because the equipment we are using, they expire. Oh yeah, they expire, that's for sure. But what about the source? The source is there. That's why we are defining the source. We are not defining the equipment and the materials and the tools we are using. This is very important that we need to have it in common about what renewable energy is. All right, if I move to the second point, why we want renewable energy, of course, environmental benefits. The thing is that as we all are, hearing and talking about the CCE or the carbon circular economy, the thing is that we are injecting the environment with a lot of emissions. Sorry, and that turns the environment badly, and that's going to get back to us in a way or another, sooner or later. So we need to work on that. And of course, it's once we control it, that's indirectly getting better in terms of efficiency, of course. And one more thing is that we want the system to be, and the grid to be sustainable. This is really important. We want sustainable system, not just in the grid, but overall. And that can be achieved by relying on renewable energy as you know, one very strong variable in the formula or in the equation. Another thing is that, you know, of course, we are going to improve the economy by many things, such as securing jobs. We would love to create jobs, and that comes with new technology. It's not just with renewable energy, but with new technologies. The beautiful thing about renewable energy is that there are still a lot of rooms for improvements. That means we are talking about a lot of new technologies that comes, you know, in the future. But the thing is that we need to move on toward the innovation. And there's a difference between innovation and invention, by the way. So if I have a chance to give the difference, I will do so for sure. One more thing is that the electricity grid, we want to improve the efficiency. It's very beautiful to have the generators very close to the grid, I mean to the load. Because if they are far away, which is the case we have right now with the grid, that means we are having losses in the grid, and that's something we would love to avoid. Yes, we can't have zero losses in the grid, but the beautiful thing is that if we have distributed generators, that they are very close to the grid, that would be beautiful. However, we need to be careful with many things, such as quality, power system resilience, power system integration. And I have a paper that I published in 2010 about integration, and I talked about the power quality in terms of renewable energy. You guys can get to my ResearchGate profile, and I'm pretty sure you will find it, or even my Google Scholar. All right. Now I would love to talk about the invention characteristics, the most common characteristic that we would love to have in renewable energy technologies. If we want to invent in renewable energy, then we need to make sure that the technology that we are coming up with is easy. It should be easy for the users. We don't want to have a very complicated system, so the end user would be, you know, stuck with a very complex system that, you know, they don't know how to use. This is one thing that we need to focus on. The other thing, of course, we need the idea to be feasible. We don't want, you know, to have that idea that would be, you know, tens of times in the cost, you know, in comparison with the other alternative solutions. That's very important, because that's what I see. You know, when I was in charge of the intellectual property department, which is, I think, the what do we call it? Yeah, the transfer technology office in King Abdulaziz University. I found, you know, many ideas that are really beautiful. However, they are not feasible when it comes to the commercialization. That idea is not going to be sell at all, because the cost is way, way, way higher than the other alternative technologies out there. And one more thing that we would love to have in our new idea is that we want to have, you know, the maintenance need to be simple. We don't want this, you know, the maintenance to be sophisticated in a way that it needs special training and frequent maintenance to keep the system up and running in a good condition. That's really important, and that's, you know, something crucial we need to have, especially when we talk about technologies that has mechanical parts in it. That's a huge dilemma when we have mechanical components in our ideas. And one more thing, spare parts. We need to have a very beautiful and efficient spare parts management, because if we are relying on materials that, you know, are not around or very hard to manufacture or takes very long time to manufacture, then we are going to have a problem with the spare parts. We need to have the system that won't face any problem in the future with the spare parts and the availability of the spare parts, of course. The good thing is that if I want my idea to move on quickly, it's good to hit a segment that has, you know, a really great number of customers. That's good. However, I'm talking here about less competition. Less competition. I don't want to get myself in a market that has thousands of companies that they're selling the product. That means if I'm gonna do that, if I'm not gonna give my product or my new technology really distinguished between the others, then the margin, the benefit margin that I will get out of it is gonna be very, very low. That means I'm not gonna get, you know, good revenues unless I you know, sell in a mass number of quantities. Again, besides the maintenance, the duration, I don't want something that would, you know, last for a shorter time in comparison with the others. So for example, I don't want to come up with a new PV system that has something else other than the crystalline in the PV that would last only 10 years, while the crystalline technology, mono or polycrystalline, we know that they last for 25 years or 30 years or even more than that. That's really important. And that's why when we go to talk about the batteries, lithium is kind of like better than the gel or the lead acid batteries. Why? Because the duration and the lifetime of the lithium is much, much better. It is about 3 to 4 times more than the batteries. So I've talked about the customer segment. It's good to have a very great number of customers in the segment that I'm going to sell my product to. So we need to put this into our considerations as well. And we need to design the system in the optimum size. I don't want to say the smallest or the largest. It depends on the optimum size that fits this idea for sure. Again, since I talked about the optimum size, we need to focus on the optimum weight as well. Easy manufacturing. Yes, we don't want to have something really complicated that is going to cost a lot in order to localize the manufacturing process. And sometimes it might be impossible to, you know, to manufacturing in the third world countries or developing countries. And in this case, we're going to have to manufacture it in any other country, such as China or something like that. We would love to have our manufacturers, you know, in our country. That's going to be beneficial, you know, in terms of jobs, politics, and so on. If you're going to talk about license and permissions, that's something really important, because sometimes I will give you an example with the biomedical devices. There's no way that you can sell it without having a permission from the FDA, Food and Drugs Association. So in Saudi Arabia, we have the Saudi FDA, and that we cannot sell any equipment until it has to go through the phases that have been defined by Saudi FDA. And usually it doesn't take a year or two. It takes a longer time, you know, to get the permission to sell the product in Saudi Arabia. Ethical, we want to have an idea that is, you know, ethical. We don't want to go beyond that, of course. Sometimes when we have a good idea, we don't recognize any side effects or side issues or other problems that got generated by this idea potentially. So we need to make sure that the side problems, you know, need to be less if we. I keep receiving messages, so I'm gonna, okay. So yeah, we don't want to solve a problem and then come up with, and that solution would generate 100 other problems that, you know, would cost more and complicate the system more and more. Some ideas good to be portable. So if the solution is portable, that's great. If not, then that's fine. Depends on the condition of the system I'm trying, or the issue that I would love to have a solution or a new technology to be involved in. And of course, we want to provide a safe solution. This is important. That reminds me of the mounting system for PVs, where I found that the edges were really sharp, and that would, cause harms to the eyes of the people who are moving around the mounting system. So that's it. This system is not safe. It's unsafe if you want to move around with. That means the mounting system need to be fixed. So this is one of the problems that maybe I will talk about later. And of course, if you want to make that idea sell, then it need to be it has to be creative. You need the people to look at it and say, wow. So if you can get that wow from the people who are going to listen to your idea, congratulations. Most likely your idea is sell. I would love to talk about some of the issues related to PV panels. Again, I'm trying to pinpoint the major issues and challenges that involved with the PV panels. That's not going to be everything for sure, but we are having a problem that is related to the delamination and internal corrosion. Here's the thing that we need to know about PVs. Most likely, they air and moist are not supposed to get inside. Otherwise, that would cause corrosion inside it. And of course, if corrosion happens, that means this is a very major degradation that will happen to the panel for sure, and the efficiency is going to go down for sure. And maybe this panel is going to be a deficit, and there's no use of this panel at all. Electrical issues that is related to wires and connections or connectors. So far, we are using MC4. Before that, there was MC3. And I don't know, maybe you're going to have MC5 or something like that. But the connectors, for example, there was a problem with MC3 that it might generate an arc flash, and inside the connectors. That's why they came up with the clickable MC4, and still it's not the perfect one. Maybe you can come up with a solution for that. Micro cracks, panels, there are cracks inside them that can be generated or caused, by many factors such as transportation, manufacturing, high temperature, ultraviolet. So when we have micro cracks, that means we are having internal heat and losses, and the efficiency is going down. So if you can come up with something to fix the micro cracks or prevent the micro cracks from happening, that's going to be great. Hotspot that is caused by shades is another problem that we need to focus on. PID effect. This is the leakage that is happening on the back of the panel because of the difference in the potential that need to be resolved as well. There are solutions for all of these things, but are they feasible solution? That's the thing. I'm not talking about issues that still persist with no solutions. No, we have solutions for that, but again, the room for improvement is still there, so you can work on that. Ironically speaking, PVs are not very good friends with high temperature. If the temperature goes high, the efficiency goes low. So we want light. If you want light, then how can we get light with no temperature? So that's another dilemma that we need to work with. Irradiance, the amount of light that is collected over the panel. Is there any technology that we can increase the irradiance in there? Soiling is another problem, especially in Saudi Arabia when we have PV farms. Of course, we are having dusty winds that can cover up the panels, and it's going to be kind of like unfunctional for a certain period of time until it gets cleaned up. Roof issues. In case if we're talking about roof, we are trying to find a way to integrate the panels with the roof without damaging the roof, of course, or without having any holes that can cause any leakage in water inside the houses or something like that because of the ceiling. And this is one of my patents, and this is the number of the patent, where I fixed with one idea a couple of things. For example, I increased the irradiance. I reduced the temperature of the collector of the panel as well with this idea, and I prevented soiling, and I can make this idea clean itself automatically. If you don't mind, ladies and gentlemen, to go to this patent number to read about it more and more, I'm pretty sure you will find enough information. And in case if you have any question about it, you can get back to me, of course, later on. Here is the improvement and the irradiance in comparison with the traditional PVs and with the one-axis PV. This is my technology here. It goes up really high. I'm publishing a paper, and most likely you will see this plot in there for sure, and you will understand it with all the equations I have in there for sure. That should the paper should be published within the next couple of weeks, inshallah. What about the challenges that involved with the grid-connected inverters? We are having, especially for inverters that are transformerless, a leakage between the grid and the PV panels that goes through the inverter. This is the problematic. Another thing is that we are, since we are working with inverters, that means we are injecting the system with harmonics. So we need to reduce the harmonics, and one of the factors that we are using to measure harmonics and calculate harmonics is the THD, total harmonic distortion. Efficiency, when we talk about efficiency, the problem is that we don't have 100% efficiency. That means the power that gets in doesn't mean the power that gets out. We have losses in there, and that losses usually get higher and higher, especially when we oversize the inverter or the power produced by the PVs are way less than the limits or the rating of the inverter. This is another problem. And one more thing is that power electronics devices have to be in a very good topologies, so that we don't have any high stress on the power electronics devices. Usually we use the term dV by dt and di by dt. We don't want to change between on and off in a way that the difference in the potential is very high. That causes stress in the power electronics and then huge degradation for that. That's why we need to have really good design for power electronics topologies, the new inverters to get around this problem. And again, at last we have the faults and deviation from standard frequency is another problem that might be caused by the poor design and bad topologies for the inverters. And it's one of the issues and challenges that we need to get around. There's one more thing, which is the active and reactive power control. Is it going to be bidirectional or one direction? That's really important, because sometimes with some regulations we need to inject the grid with reactive power, especially with those grids that are claimed as weak systems. This is another patent that I have, which is a multi-level inverter. I came up with this topology and it has been patented. And with this one, I think I already have a paper for this one, but what I accomplished with this topology is that it has lower switching losses. I use a very simple technique for controlling this topology, which is the very well-known pulse width modulator. It is way easier than the other controlling techniques, and the stress is very low. With I made it really low for that goes across the switching devices, and of course I mitigated the harmonics there as well. So guys, if you want to read about this patent, please refer to this one. I'm pretty sure you will find the other multi-level inverters. They are very close to each other. I have different topologies, but you know, for the sake of time, I just put this one, and most of them are having you know, the similar features there, except there are some changes and differences in the topologies in there. So briefly speaking, these are the four main features I have with this topology. And here's the output, the experimental work that I got, you know, out of this patent, because I have it installed and it's in the benchmark. I hope they did not disconnect it yet, because we are moving from one idea to another. But as you can see, you know, with the spectrum here, we don't have that much of wasted energy in the other harmonics. They're all in the fundamental, or you know, at the multiples, where even with the filters, we don't need to use huge filter, or maybe we don't even have to use filters at all, because the total harmonic distortion amount is still within the limit, as in comparison to the IEEE or IEC standards. Thank you very much, and I hope I didn't, you know, take too much out of your time. And if I have enough time for your question, I'll be more than happy to answer that.
Yes. Thank you, Dr. Hussain, for what you have given to us for information. I think we have time for some of the questions, but can you give more information about the first patent that you showed? Can you go back to it?
I will try to do that. Okay. Are we talking about
the clear, what do you call it?
This one?
Yeah, this one. This one. When we saw the graph, we saw a good increase of gaining the energy of the sunlight by using your technology. But why in December it's just going down? If you go to the graph.
All right. Let me show you here. This is for the September only, but the thing is that I'm relying with this idea on mirrors, where the idea is the panels are getting the light from the sun directly and reflected from the mirrors. Here's one thing we need to know about panels, is that usually panels get the most out of the photon that it receives when the sun is perpendicular over the panels. So what I did in here is that I put mirrors to to have the light perpendicular over the panels, and during the noontime there's no reflection, so it's gonna act exactly just like the other technologies. But before that, we are having the regular beam and another beam. So we call it two sun, where each sun is about 1,000 watt per meter square. So that's why we are having two suns. So this idea is making the regular panel work a little bit more of like the concentrated cells. If you guys are familiar with the concentrated cell, not the thermal one, with the one that can focus the light, in the center. So that's why we are having this one in the middle, where the mirror doesn't, work, doesn't produce, doesn't reflect the light at all. But there's one idea that I can work with. I did this already by moving the mirrors to the sides, and if that happens, then this shape is gonna, this shape is gonna get smoother here for sure.
Yeah, I got that. So your idea is instead of having like a tracker to move the whole panels, you have the mirrors. The mirrors are moving as a tracker to focus the photons to the PV panels. Is that right?
That is correct. Here is the thing. The idea of the mirror is almost there. I didn't bring in anything new about the mirror. It's there already. But the thing is that I'm having this radiation system where I got the benefit of using the actuator here to cool down the fluid inside here, to cool down the panels. And those actuators are used as well to control the angle of the mirrors that can produce more power out of it. And that's where my patent is concentrated in. It's in the actuators here, using the mirrors. But your idea, what
Doctor,
you from the idea is correct.
Doctor, your patent is brilliant. It is.
Thank you, Mr. Robert.
Yes, I love it. I love it. It's a great idea.
Yeah, and I think the one concern about the BF panels that the concentrations of photons should be equally distributed in the whole panels. Is that mirrors are doing that? Because I feel the concentration maybe will be increased in one cell, difference from the other cells. But I think you have done it, you have tested. I think just I'm curious about the result. Do you have the equally concentration of photons in this technique?
Well, I have done this idea experimentally, and the results that we got is very close to what we have in here, and most likely within I assume 4 to 5 months, we will publish a paper of this idea that shows the experimental work as well. So the distribution of the photons here, when we are talking about cells, they are very close. Keep in your mind that, all those cells are connected in series. All those cells are connected in series. So let's say, for example, if you want to represent one panel, they might be represented, for example, as one whole string. So if one of them has, for example, more light in it, the other ones, would have very small difference that can be generated as heat. So eventually they will distribute, they will all produce electricity. They are not gonna malfunction. However, the difference that might generate, some heat dissipation in some of the cells. This is one of the problems that we call internal mismatches. But it shouldn't be a major problem, if the differences are really, low. And with the mirrors, as you can see here, they are distributing the light, uniformly over the panel.
Yeah, it is a very interesting and very good idea, to use the mirrors, and also the idea of cooling the panels. It's very important, especially in our areas. I really congratulate you for this idea. And
I have a question on this. Wouldn't this work better if you moved the panels, the reflecting panels, to the outer edge on each side, so that there's no blockage of any sort of incoming rays from above, but you always have the ability to deflect the rays onto the panel from a better angle? I'm looking at this, and unless some of the rays pass through the panels, you still might get areas of the panel that the light is blocked and it's not reflected onto it. And my second question is, do each of the panels move independently so that they can concentrate their reflective capability in the best possible way?
Great. For the first question, yes, we are working on the other idea where, the mirrors are going to be on the sides of the panels.
Yes, great.
The only problem, my guess is that since they're going to be on the sides of the panels, that means the reflected beam is not going to be perpendicular over the panel. This is number one, but let's wait and see what the results are going to look like, in comparison to this one. Number one. Number two, why we're using actuators here? Because most likely we're not doing any blocking. Because if the light that comes from, for example, from the east, and it hits this mirror is gonna, of course, cause shadow over the other mirror. That's why we're having this actuator to raise it up, to catch the light to be reflected over the panel without having any problem with this mirror at all. And one more thing, what you have in here is that I put into the consideration the shade that caused from, for example, the first mirror. And most likely you will see that, you know, in the first paper that I will publish now, and then the second paper, which is going to be after, for example, after 4 or 5 months that we will get out of it. So I put into the consideration the shades that caused by the mirror, whether, you know, the sun comes from the east or goes all the way to the west. There's one beautiful thing that I expected a question, you know, about this patent, is that number 4, how, or number 3 and 4, how, you know, this idea can prevent any soiling. With this idea, what I did is that I put, you know, sensors in case if it has an alarm of a dusty wind, then what's going to happen is that, you know, these 2 mirrors are going to cover the panels. They're going to go flat, and then they will be attached to the PVs in a way. This figure is not, you know, perfect, by the way, ladies and gentlemen. So it's going to cover the panels. So when that wind goes away, at least we saved the panels a little bit, you know, from accumulating any dust over it.
Can I make a suggestion?
Sure.
The way your panels are situated, 2 things. One, if you were able to make a system where the panels themselves can move in parallel to each other, back and forth on the sides that they're located on, you know, have a channel and have them being able to move so they can both move next to each other or apart. That's one thing. But the other thing is, in conjunction with that, if you could rotate those panels and on one edge or on both edges of the panel, put like a windshield wiper type blade, so that when you lower the panels to their lowest point, that blade can be just touching the surface, and then you rotate the panel and you can wipe the surfaces clean.
Bob, if you allow me to call me Bob, I think you are kind of like reading my mind. However, there's one thing that might be problematic in your beautiful suggestion, is that that might cause scratching the panels. So what I did with the step number 4, and you will see that in the patent, is that one technique that I, you know, can use these 2 mirrors for, is that I can spin them in an adequate RPM to blow the dust that is accumulated, you know, on the panel without touching it, because I don't want to cause any scratches. And this is one of the problems, you know, with many cleaning systems, you know, for TVs. So I prefer to do the fan, you know, technique and the air blowing technique rather than touching it. But thanks for your suggestion, for sure. Yeah, thank you very much.
Thank you.
Yeah, that's great. That's great.
Thank you, Dr. Hussain, for your presentations. And I think for the time being, we have to move to the next speaker. But Dr. Hussain, there is a few questions in the Q and answer box. Gladly, I would like you to look over them. There are some questions regarding your speech, if you
and could you go to the last panel of your presentation so I can capture your contact information?
Sure. I'm doing that, and I will get to the questions. All right, as I can see here, PID is all right. When we talk about this is one of the questions that I got from Ahmad Ibrahim. He's saying, what does PID means? What does it mean? It means panels. You know, there's a potential difference between the panels and the ground, and that causes leakage from the panel right to the ground. So instead of that panel sending power over the wires to our, you know, houses and the load, no, there's leakage that happens right behind the panels. And there's one project that I'm working on, or I will be working on shortly, inshallah. I'm arranging that.